For your warm-up, you're asked to calculate what's called in power using exponents and bases. And so I'm going to show you how to do that. And first, let's do some vocabulary before we start. So we know that we have this number over here, and it has this tiny 2 up top. And it is a small 2. I want to emphasize that we're not working with like these random things. This is a small 2 that's at the top. Do not write 102. That is not the same thing. This bottom section, which I'm going to highlight in orange, this is called the base. This top section, which is this 2, is called the exponent. And together, these two things make what's called a power. And the way we would read this is we would say 10 to the power of 2. So you might ask, well, what does that even mean? Well, what it means is we've done multiplication, which is repeated addition. And then we've done division, which is repeated subtraction. And now we're doing powers, which is repeated. I'm going to put this purple. Repeated multiplication. I didn't finish the word, but you get the idea. So if I head back over here, we can see what that means by giving some examples as we saw the warm-up. If I have number 1, it says 10 to the second power. And the way I would write this is this would be 10 times 10. It's a repeated multiplication, and I did it 2 times, which is equal to 100. That's number 1. Then I have number 2, and that says 10 to the 5th power. And so this is going to be 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5 times. So that's going to be 1 with 1, 2, 3, 4, 5 zeros. 0, 0, 0, 0, 0, which is 100,000. If I look at number 3, it says 10 as my base, and 3 is my exponent. That's going to be 10 times 10 times 10, 3 times, which is going to be 1 with 3 zeros, which is 1,000. If I look at number 4, my base is 10. Try it. My power is 4. My exponent is 4. So we would say this is 10 to the 4th power. So this would be 10 times 10 times 10 times 10, which is 1 with 4 zeros. 0, 0, 0, 0, which is 10,000. And if I finally look at number 5, my base is what? 10. And my exponent is what? 7. And so this would be 10 to the 7th power. So I'm going to have 10 times 10 times 10 times 10. 1, 2, 3, 4 times 10 times 10 times 10. So that's 1, 2, 3, 4, 5, 6, 7. So this is going to be 1 with 7 zeros. 1, 2, 3, 4, 5, 6, 7, which is 10 million. Which is a pretty big number. So as we move forward in this lesson, we're learning about exponents. The best way to think about it is, once again, all this is we are simply doing repeated multiplication. That's it. It's just repeated multiplication. The other thing to remember is this right here is not, that's a tiny 2. And it's above the number, not straight up, it's to the right, and up a little bit. If you're doing the expressions challenge, this is extra credit. It says, recall that an expression in math is a number or a combination of numbers and operations. So the number 8 is an expression. 2 times 2 plus 4 is also an expression. Anything basically that has numbers but does not have an equal sign would be an expression. So 2, not what I wanted. So I could do 2 plus 3. This would be an expression. But as soon as I do 2 plus 3 equals 5, all of a sudden it becomes an equation. In this equation, there's one expression and then 2 expressions. But together with the equal sign, it makes an equation. When we look at number 1, it says write an expression that is equal to 10 using only 4 2's and any number of math symbols. And so let's think about this. All it's asking me to do, if I had 1, 2, 3, 4. Well, I could do 2 times 2 is 4, and then 4 times 2 is 8, and then 8 plus 2 is 10. And so this expression is equal to or equivalent to 10, because 2 times 2 is 4, 4 times 2 is 8, and then 8 plus 2 is 10. 4 times 2 plus 2. This would be 8 plus 2 is equal to 10. And just as a reminder, the way I'm setting this up, if you remember from 5th grade, we have this thing called PEMDAS, or you might have used GEMDAS. That means that we do parentheses first, then exponents, then multiply, then divide. Sorry, multiply and divide, whichever comes first, and then add and subtract, whichever comes first. If we go down, number 2 and 3 you should do on your own. Let's go over it. It says, write an expression that's equal to 8 using only 4 3's and any number of math symbols. So I have 3, and 3, and 3, and 3. So if I think about this, I know that 3 times 3 is 9. I know that 3 divided by 3 is 1. And so if I divide this, and I multiply this and subtract in the middle, I know from GEMDAS right here that I need to do my multiplication and division first. So 3 times 3 gives me 9, and 3 divided by 3 gives me 1, and 9 minus 1 is equal to 8. Number 3 says write an expression that equals 20 using only 1 2 and 2 4's. 2, 4, and 4. And this one might be tricky. My hint is that you use exponents. What you want to do here is if I do 4 to the power of 2, and then I add 4, 4 to the power of 2 is the same as 4 times 4, which is 16. And 16 plus 4 is equal to 20. When we talk about squaring and cubing numbers, just as a review, remember that when I have an exponent, I have this thing called power, which is repeated multiplication. And then I have a base, which is the bigger number, which is my regular number. And then I have my exponent, which is small and up top a little bit and to the right. And it tells me that exponent tells me how many times I multiply. So in this case, 2 times 2 times 2 times 2 is the same as 2 to the power of 4. When I look down at 1, let's go ahead and see if we can remember this. It says identify the base and the exponent in each power, then write the power in words. Go ahead and try to do that. In this case, I'm going to write B for base is 7. The exponent, E, for exponent is 5. And the way I would write it is I would say 7 to the power of 5. B, the base, is 4. The exponent is 8. And the way I would say this is I would say 4 to the power of 8. In geometry, these powers, and particularly when we have a number to the power of 2 or a number to the power of 3, it has a special shape. So a number to the power of 2 is just a square. Because if you remember from 5th grade, a rectangle is length times width, but a square is just the same, side times side, which is the same as side squared. So how can we write these rectangles using symbols instead of the shape? For A, we could say that this is 9 times 9, which is equal to 81 centimeters squared. Or we could say that this is 9 squared. And when we have 9 to the power of 2, the special word for it is squared. Or we could say 9 to the power of 2. On B, we would have 2.75 times 2.75. Or I could say that this is 2.75 squared because I multiplied it twice. And remember that this is going to be meters squared because we're in 2 dimensions. If you go to C, C says that we have 2/5 times 2/5, which would be equal to 2 times 2 is 4. Remember, we multiply across. And 5 times 5 is 25 inches squared. One thing to remember, this would be 2/5, and we need to put it in parentheses because we want both numbers to be squared. What would not be right is if we had 2/5 squared, because all that means would be that I'd do 2 times 2, which is 4, but then the 5 would stay the same. And that's not right. Don't do that. B would be 7 times 7, which is equal to 49 feet squared. But it could also be 7 squared, which is equal to the same thing. In 8th grade, right here it's talking about perfect squares. Those are squares of an integer, like 2 times 2 is 4, or 3 times 3 is 9. So when you get to 8th grade, those are called perfect squares, but that's not a vocabulary word that you need to remember right now. Incidentally, when you get to 8th grade, if it's 2 times 2 times 2 is 8, or 3 times 3 times 3 is 27, that's called a perfect cube. Again, not something you need to remember right now, but it is something that will be important later. We do have these things called cubes, and so this is 3D. And again, if we remember from 5th grade, we had a cube, or a rectangular prism is length times width times height. And a cube would just be side times side times side. So in this case, I'll do 1. This would be 2 times 2 times 2, or it could be 2 cubed, which is 2 times 2 is 4, and then 4 times 2 is 8 centimeters cubed. And we put that 3 here because we're in 3D. Notice this is not centimeters 3. It is centimeters to the power of 3. Centimeters cubed. Please do not make that mistake. You guys do the rest. B would be 4 times 4 times 4, which is the same as 4 to the power of 3, which is equal to 4 times 4 is 16, and 16 times 4 is 64 inches cubed. C would be 3 times 3 times 3, which is going to be 3 times 3 to the power of 3, or 3 cubed, which would be equal to 3 times 3 is 9, 9 times 3 is 27 feet cubed. B would be 5 times 5 times 5, otherwise known as 5 to the power of 3, or the fancier name 5 cubed. And 5 times 5 is 25. 25 times 5 would be 2550, 2500, 125 millimeters cubed. Again, we're in 3D. In activity 1.2, we're going to need to go to the cutout where you cut out some shapes and we're going to match them. And I just want to remind you that with our geometry, I have length times width. But if I were to change this a little bit and have a longer rectangle that's cut in half, the way I would write this, say this was 3 long and then I had 2 and 5. I could write this as 3 times 7, or I could write it as 3 times parentheses 2 plus 5. Notice the length is still 2 plus 5, and the width is still 3. And so I have length times width. The width happens to be 2 things added together. Let's figure out which of these models go together. Some of them are going to be really easy, and some of them won't be. I'm going to label them and then color code them. So let's start with number 1. We're going to call this A. And so A is 3 times 2. Where can we find a rectangle that's 3 times 2? And the reason I say it's a rectangle is because it's 2 numbers multiplied, which means we're in 2D, versus 3 numbers multiplied would be 3D. 3 times 2. Boom, here it is. A. This is 2 times 3. Up here is 2 times 3. Let's do B, also in red. My next one is 3 times 2 squared. So this is interesting. It's 3 times 2 would be 6, but then it's squared. So I'm looking for something that would be 6 squared, and the shape is going to be a square. Oh, look. Here's this, and here's this. So that's 3, and then there's 2 of them. So that would be 3 times 2. Then it makes a square, because this side is 3 times 2, and that side is 3 times 2. So this is going to be B, and this is going to be B. Let's use orange for the next color. This guy, this is a 3 to the power of 3, and this is 2 to the power of 3. So where do I see 3 to the power of 3 and 2 to the power of 3? The reason I say it's to the power of 3 is because it's in 3D, and there's 1, 2, 3. So we're going to say this is called C. And down here I see it, 3 to the power of 3 and 2 to the power of 3. So this is going to be C. The next one we see is cubed because it has the 3 here. And so we're looking for something that's in 3D. So it could be this one, but that's 2 cubed. Down here, this is interesting, we have a cube, but it's 3 and 2 together. So this would be 3 plus 2. Is that what we have? Here we have 3 plus 2. That looks great. So that's 3 plus 2 cubed, 3 plus 2, 3 plus 2. 1, 2, 3. So that's multiplied 3 times, cubed. So B is right there and right here. So the next one, put it in yellow. Here, this is 2 and 2 and 2. It's in 3D, so that's 2 cubed. So this is going to be E. I'm looking for 2 cubed. There she is. E, 2 cubed. The next one's super easy as well. This is going to be F. And that's 3 squared. So let's find a 3 square. There's my 3 squared. F right here. Let's find G. This one is a little bit tricky. I've got 3 by itself times 2 plus 3. So I've got a length, 3, and then a width, 2 plus 3. So where can I find something that's a rectangle with a length of 3 and then a width of 2 plus 3? That's 2D, but that's not a rectangle. That's not a rectangle. This one has a length of 3 and the width of 2 plus 3. So I think that's it. Because I have 3 times 2 plus 3. 3 times 2 plus 3. Next one is H. Here, we've got this weird combination. I've got 2 things. This is a 2 square. And then this is just 3 times 1, which is 3. So where can I find 3 and then a 2 square? That looks like it over here. H. There's 3. I see the 3 times 1 is 3. And then the 2 square, which is the 2 square. Let's look at I. So here I have a 3 square, and then I have a 2 square. Where do I see 3 square and 2 square? Here it is. I. 3 square and a 2 square put together. The next one is I have a 3 plus 2, and it's squared. So it's 2D, and it's a square. Where do I see a square? That's right here. 3 plus 2 times 3 plus 2, and it's a square. So this is going to be J. The last one is 3 times 2 plus a 3 by itself. And here I have 3 times 2 plus a 3 by itself. And so this is K. If you want extra credit, you can make your own. It says think of a numeric expression, draw a model to represent it. As an example, I could say that I want to draw, what do I want to draw? Let's draw, I'm going to draw a rectangle. How would we cut it up? I want this to be 2, and then I want this to be 3, I want this to be 5. So the way I could write this would be length times width because it's a rectangle. The length would be 2, and the width would be 3 plus 5 put together. It says trade a model with her classmate, write the expression. A different way I could do it is I could draw this rectangle. And so this could be 2, and then this could be 6. So my length times width times height. My height is 2 plus 6. As we see that right here. It's 2 things together. Then my width is 5, and my base is 4. So I have 4 times 5 times 2 plus 6, because my height here is 2 plus 6.